Okay, so we're doing mixed numbers to improper. That's not that difficult of a topic. And we can move this up here. All right, so changing a mixed number to an improper fraction. Okay, let's see. Take a mixed number. A mixed number is made up of a whole number, like this, and a fraction. So you want to change this to an improper fraction. An improper fraction is where the numerator is equal or greater than the denominator. So how do we do that? Well, the little trick that you know is that you're going to have to multiply these two and then add the product to the numerator. So it helps if you put those two things up there. 5 times 3 is 15. Oops, sorry. That's not what you have to do. Here we go. 5 times 3 is 15, plus 4 is 19. And that gives you 19 over 5. So they're both equivalent to each other. They're just in different different ways, I guess. So one's a mixed fraction, one's an improper. So let's try another one again. 7 and 9 over, I don't know, 10. Okay, multiply these two and then add that to 9. So 10 times 7 is 70, plus 9, 79 over 7. Okay, want to do one more? 5 and, I don't know, 7 eighths. Multiply these two. 8 times 5 is 40, plus 7, 47 over 8. That's how you change a mixed to an improper. Okay, little review. Everything's a little review. Improper to mixed, so let's go backwards. So let's say you have 45 over 10. It's a bad one, but we'll do it. So change this to a mixed number. You're going to ask yourself, how many times can 10 go into 45? And that's 4 times. How many left over? 5 over 10, which you can simplify to 4.5. Okay, another way of thinking about this, well, let me use another problem. 72 over 15. Okay, one way of thinking about this is actually doing the division. So you're going to divide 72 divided by 15. And 15 goes into 7, 1, 2, 30, 45, 60, 4 times. And that's 60. And you have a remainder of 12. So the 4 over here on the quotient is your whole number. 15 can go into 72 4 times, which is 60, and you have a leftover of 12. Okay, that becomes your numerator, and your denominator is the same. To check your answer, you can work backwards, or you can do it again. You can multiply 15 times 4, which is 60, plus 12 is 72, and that's exactly what you have over here. Okay, another one, let's do an easier number. 29 over 4. 4 goes into 29 7 times. 1 left over 4. Let's do division here just to show you. That's 29 divided by 4. Let's see if that works. 4 goes into 29 7 times, which is this whole number right here. Okay. And you have a remainder of 1, which is your numerator right here. And 4, because the denominators don't change. Okay, so very briefly, how to change an improper to mixed. What do we have? Adding fractions and subtracting fractions. Ooh, okay, our favorite. So, with like, that means with like denominator. So let's take something very simple. 3 over, I don't know, 10 plus 4 over 10. When the denominators are the same, you can add them. Okay, because you're adding same pieces, they're the same sizes, so that's easy enough. So that means that you have 7 over 10, and that's it. You add the numerators and you keep the denominators the same. So you have 7 pieces that are 1/10 each. Okay, subtracting is the same thing. 8 over, I don't know, 20 minus 3 over 20. Okay, you subtract the numerators. 8 minus 3 is 5. Denominator stay the same, 5 over 20. And in this case, you can simplify 5 over 20. Divide top and bottom by 5, you get 1 over 4. Okay, so when the denominators are the same, life is easy. Add the numerators, and keep the denominators the same. Okay, so I will do one with mixed numbers. Okay, and remember, for these two problems up there, there was not much to do. But if you get something like, when the screen stops moving, let's say 3 and 4/7 plus 5 and 2/7. Okay, remember what we did in class? We did plus, we're adding in this case. Okay, draw a line in the middle here because we want to separate our fraction from our whole numbers. Okay, and let's do the fractions first. Our denominators are the same, so there are nothing to do here, so we'll just add 4 and 2, that gives you 6. And the 7 stays the same, and our whole number, 3 and 5, is 8. Our fraction is a proper fraction, so there's nothing else to do. You can't simplify it. And our final answer is 8 and 6/7. Subtraction is the same thing. I don't know, 2 and 3/5 minus 1/5. Okay. Denominators are the same again, so 5 stays, and you do 3 minus 1, which is 2. And on this side, 2 doesn't subtract with anybody, and it's just 2 and 2/5. Okay, so it's pretty easy when our denominators are the same. When they're not the same, okay, and let's take a simple example like 4/7, and you're adding that to 3/9. Okay, so if you're adding these two numbers, well, you know that you can't add them because the denominators are different, so you're going to have to switch to an equivalent expression, equivalent fraction, where they both share the same denominator. So you're going to have to find the least common multiple of 7 and 9, which in this case 63. Okay, so figure out that 9 times 7 was 63, so you do the same thing on top. 3 times 7, which is 21. In this case, 7 times 9 gave you 63, so you multiply the top by 9, and you get 36. Now you're ready to add them. The denominator is 63, and 36 plus 21 is 57. Final answer, 57 over 63. Okay. Same for, let's do one with mixed number, and let's do 4 and, I don't know, 4/5 minus 1 and 1/3. Okay, so let's split these up, and in this case, our fractions denominators are different, so we have to adjust. Okay, we have to find two equivalent fractions where they share the same denominator. So LCM of 5 and 3 is 15. Okay, so it was 3 times 5 to give you 15, so you do the same on top, which gives you 5. 5 times, and well, LCM is 15, so it's 5 times 3. And then obviously 4 times 3 on top, and it gives you 12 over 15. Okay, we're not borrowing anything. 12 minus 5 is possible to do. You can take 5 from 12, so we don't need to borrow. But these no longer are in play. Okay, so you got your two new fractions. Denominator is 15. 12 and 5 is 7 over here. And on this side, I have no idea what that's supposed to be, but it's supposed to be a subtraction sign. And 4 minus 1 is 3. Final answer, 3 and 7/15. Okay, so easy enough. Now, I want to tackle a couple of problems where you have to borrow. Okay, and let's just move this. Alright, so let's do a couple of problems where borrowing is necessary. And, alright, so let's take 8 and 1/4 minus 5 and 2/3. Okay. Like separating my fractions from my whole number. Well, you realize that A, you can't subtract these two, so you got to find an LCM, and I'll change colors. The LCM between 4 and 3 is 12, so this one was times 4, so top times 4, which is 8. So LCM is still 12 here, so it's 4 times 3 to give you 12, so you multiply the top by 3, and give you 12. Okay. I'm going to cross this out because a lot of numbers gets confusing. So you don't need these two anymore. You have your two new fractions. And, oh, I made a mistake. Here, okay, here is supposed to be a 1 times 3 is 3. So now you notice that you can't do 3 minus 8. Not yet, at least, until you learn how to subtract integers. But you can't. So we need to borrow here. So we're going to go to the 8 and borrow 1 whole. So 8 becomes a 7. And they're going to lend us a whole piece here. But you're not going to write 1. What you end up borrowing is 12 over 12, which is 1. So you're going to add these two, and you get 15 over 12. Now you're ready to borrow. I'm sorry, you're ready to subtract. Okay, again, these two don't count anymore. Those are gone. Your new fraction is 15 over 12. So 15 minus 8 is 7. 12 and 12 is just same denominator. And on this side, 7 minus 5 is 2. I'll do one more. Let's do 3 and 2/3 minus 1 and I don't know, 9/10. Okay. We need to find an LCM because they can't be subtracted as they are. So LCM between 3 and 10 is 30. Okay, so times 3. So 9 times 3 is 27. And over here is 3 times 10. So 2 times 10 gives you 20. So again, you'll see that you can't do 20 minus 27. So this guy here, this fraction needs to do a little borrowing. So it's going to borrow from 3. And 3 is going to throw a 20 over 20 over this side, which is a whole unit. Okay, 20 over 30. Oh, sorry. It's going to throw a 30 over 30. Okay, look at your denominator. Denominator is 30. So it's 30 over 30. Okay, that means one whole unit. So, and then we're going to add those two. And you get 20 plus 30 on top is 50 over 30. So our new fraction here is 50 over 30 and 27 over 30 at the bottom. Now you can subtract. 15 minus 27 is 23. And 30 over 30, same denominator. And here the 3, became a 2. And 2 minus 1 is just 1. Final answer, 1, 23, and 30. Okay. What's the next one? Ooh, I didn't know what to call it, so I wrote adding the needs should be written as needs to be adjusted at the end. I'm gonna come up with a better statement. So let's see what that means. So let's take a fraction, 5 and 2/3. We're going to add that to 4 and I should have picked a better number. You know what? Let's do this. Let me erase that. Instead of 2/3, let's go 5 and 4/7 plus 4 and 6/7. Okay, let's just focus on the adjustment at the end. Well, denominators are the same, so good. Don't have to find the LCM or anything. I can just simply add. And I get 4 plus 6, which is 11 over 7. And at the end here, I have 5 plus 4, which is 9. Okay, this is a mixed number, but it's not a mixed number. Okay, that is in the right format. Okay, so like I said, the mixed number is not in the right format. It should not be a whole number, and an improper fraction should be a whole number and a proper fraction. So we need to make a little adjustment here. So 11 over 7 over here should be rewritten as, well, 7 goes into 11 one time, 4 left over, and 11. Now we have two whole numbers, a 9 and a 1, and those two can be put together to give you a 10, and the fraction 4 of 11 just will stay the same. So our final answer is 10 and 4 of 11. That's what I mean by adding that needs to be adjusted at the end. Okay, so let's do one where we have to do the whole thing. 2 and 7/8. 2 apostrophe 7/8. 3 and, I don't know, 4/5. Okay, this one needs to find an LCM, and the LCM is 40. Okay, this was times 8, so it's 4 times 8, which is 32. This was times 5, which makes the top, times 5, which is 35. We're ready to add. Okay, this is addition, so 35 and 32 is 67 over 40. And on this side we have 3 plus 2, which is 5. And again, a mixed number where it's not in the right format, so we have to make a little change. Okay, this improper fraction can be written as a mixed number, and that 40 goes in 67 one time, 27 are left over 40. Now you'll notice that there's a whole number on each side, a 5 and a 1. So those two can be brought up together, 5 and 1. That can make us 6, and we can just copy that other fraction over here, 27 over 40. And that would be our final answer. Okay, and I think there's one more thing I need to tackle, is multiplication. Oops, and I didn't write that, so I'll just write it. Multiplying with fractions. Multiplying with fractions. Okay, wow, that was ugly. So, multiplying fractions. Ooh, the easiest of all of them. So let's take an example here. 3/4 times, I don't know, 2/7. They're multiplying fractions. Okay, the rule is just numerator times numerator, denominator times denominator. And 3 times 2 is 6. 4 times 7 is 28. Which you can simplify to 3 over 14. Okay. We'll do another on the side. Now let's say 5 times 2/7. Well, one's a whole number, the other one's a fraction. Okay, that's not that big of a deal. Just put the 5 over 1, makes it a fraction. And now you multiply. 5 times 2 is 10. 1 times 7 is 7. Don't leave it as an improper, change it to a mixed number. So 7 goes into 10 one time. 3 left over 7. And another one we can do, let's just do mixed numbers. Okay, 2 and 1/3 times 4 and I don't know, 2/5. You're not going to multiply 2 times 4 and multiply 1/3 times 2/5. Not what you want to do. You want to change these two to improper fractions. Okay, 3 and 2 is 6, plus 1 is 7. 7 over 3 times 5 times 4 is 20, plus 2 is 22 over 5. So now that they are an improper fraction, they're good to be multiplied. And 7 times 2 is, I don't know, 160 something? 4? 154. 3 times 5 is 15. Okay, and don't leave it like that. Improper, you can leave it as a mixed number. 15 goes into 154 10 times, because 15 times 10 is 150. And then it can't go any more, but you have a leftover of 4 over 15. Okay, so there you go. Multiplying with whole numbers, fraction, fraction, fraction with mixed numbers. Okay, when it's mixed numbers, make sure you change it to improper. If it's a whole number, put it over 1. And like I said, of all the operations with fractions, this is the easiest one because there's not much you have to do. Okay, yeah, that's about it. Tomorrow you'll do division. I want to devote a whole day to division because we want to practice the models. Okay, that's that for this. Oh, I forgot a password for yesterday, like a password, little code for day 2. So day 3 is going to be I hope you can't, oh my god, snoring. That is funny. And then for day 2 you can go back and put what can you put for day 2? The word is giant. Okay, giant. For day 2 and day 3, snoring. Alright, that's it.